13.5. Our book calls this section probability models. But what we're really talking about is two-way frequency tables. So I'm going to draw a frequency table, a two-way frequency table that we're going to use for for all of our examples, because we'll be able to get all of our information. So a two-way frequency table is very much like a normal frequency table, except it has two categories rather than one category. So I'm going to do a category for people that caught cold, people that did not catch a cold, and this column will be for the total. And then we're going to do categories going the other direction also. So we're going to put in the category for exercise. We're going to put in a category for no exercise. And the total. So we have 8 people that exercised and caught cold. We had 30 people that exercised and did not catch cold. The total number of people that exercised then is how much? 38. We have 10 people that did not exercise and caught cold. And we have 2 people that did not exercise and didn't catch cold. So our total this way is 12. And then how many people caught cold? 18. And how many people did not catch a cold? How many total people do we have in our entire list? 50. Well, you guys know how to use a table already. So we're just going to use this two-way frequency table now to calculate probabilities. So we know we have our numbers. We just need to know how to use those numbers to calculate our probabilities. We're going to go about it the same way that we've done with everything, favorable over total. We just need to know where to pick our favorable and where to pick our total depending on what the question asks us. So a table, when we lay it out like this, is called a two-way frequency table. Because I have information for 2 categories: whether or not someone exercised and whether or not somebody caught a cold. So we have information about both. And we can use our table to find probabilities, experimental probabilities, because I don't know, some doctor kept some data to figure this out. So it has to do with measuring, has to do with observation, so it'd be experimental probability. So we can find experimental probabilities for various things. So let's start with an easy example. So we're going to use this table for all of our examples. So we want the probability that, and we're saying we surveyed 50 people. We're saying that those 50 people are going to represent a bigger group of people in general. So say there's, at our school, this is, someone did a survey, so we're going to say that these 50 people more or less are like people in our school. So we want the probability that some random person caught a cold and did not exercise. So that's what we want to use our table to figure out. So we're going to do favorable over total, just like we did before. So our favorable, how many people caught cold and did not exercise? So 18 is the total number of people that caught cold. So we're looking for only the number of people that caught cold and didn't exercise. So we're looking for this one, caught cold and didn't exercise. So our favorable is 10. And how many patients did we look at for the survey? 50. Probability equals 10 over 50. The favorable is the number of people that are in both categories that we're looking for. So this would be 1/5, or 0.2, or 20%. So we're going to guess, based on our survey, that about 20 people would catch a cold and not exercise. So that one's pretty easy. Favorable over total. Well, now we're going to look at a different kind of probability. We're going to look at the probability just in a certain category. And we call that kind of probability a conditional probability. So this is our two-way frequency table. This is our we can find the probability for one piece of a category. Now we're going to talk about the probability inside a specific category.
So does this first example we did have like a
It's just a probability from the table. It's just like we did with our regular frequency tables. That would be our relative frequency, like we talked about before. So the relative frequency of people that caught cold and did not exercise is 20%. That's a good question. So conditional probability. What we mean by conditional probability is we want to find the number of chances that an event will occur or will happen given or after we already know that some other event already happened. So that's what we mean by conditional probability. We want the probability that something happens after we know that something else already happened. So that's kind of like we talked about with the marble game. What's the probability of, if we're not putting the marbles back in the bag, what's the probability that we pick out a red given that 2 reds have already been picked out of the bag? So that's kind of what we were working with there. Is we knew that a certain number of marbles had already been picked out. We want to know what the probability after that already happens. So that's what we're talking about with conditional probability. The way that we write this, the way that you'll see it in our book is P of B, and then we put this bar, and then A. So this is probability of B given A. So this is the way you'll see it, hear it spoken about. So this is the probability of B given A. The probability that B happens after A happens. I'm just trying to give you some different ways to think about it. So probability B happens after A happens. So we know that A is true already. And we can use a two-way frequency table to find conditional probability. It's one nice thing about two-way frequency tables. So we're going to go back to our table and figure out this example. We want the probability One kind of different thing about probability in math is there are a lot more words. It's true in geometry in general. So probability that someone did not catch cold, given that they didn't exercise. So we know already that they did not exercise. That's the given. That's what given means. We already know that. So in a two-way frequency table, when we have a probability like this, and I'm just gonna write it out, P of no cold given no exercise. The way we figured this out from our two-way frequency table is very easy. We only look in the given category, in the category that says given. So we only use numbers from the given category. So let's look back at our two-way frequency table. So our given category is no exercise. So we're only looking in the no exercise category. We can ignore everything else. That's all we have to look at. So the problem asks us, what was the probability that someone did not catch a cold given that they did not exercise? So how many people in the no exercise category, we're just looking in the no exercise category, did not catch a cold? 2. That's going to be our favorable. We're only looking in the given category. And what's the total in the given category? 12. We're only looking in the given category. So when we're finding conditional probability, and it says probability of something given something else, we can basically cover everything else up. I'm ignoring this, and I'm ignoring this. I'm only looking at this category. So our favorable is did not catch a cold, or 2, and the total is 12. And that's all we have to do. So the probability is 2 over 12. We only looked in the given category, and we can reduce this or simplify to 1/6, which is about 17%. So about 17% of the people did not catch cold given that they didn't exercise. So for conditional probability, two-way frequency tables, I'm going to ask you for the probability of something given something else. Only look in the given category. So do we have questions on that example? All right. A lot of times what I remember is what confused a lot of people is just reading the probability this way, forgetting what this slash between the B and the A meant. So remember that this is telling us the probability of B given A. This little bar you can read as given. All right, so let's do another example with our frequency table. The probability that someone exercised given they caught cold. So we would write this as probability of exercise given cold. So we're only going to look in our given category. So our given category here is they caught cold. So now we're going to go back to our table and look at the caught cold category. Here's the caught cold category. So this time our category goes up and down instead of left and right. So I can, that's another reason they call it a two-way frequency table, is I can look in the columns or I can look in the rows. So I'm only looking in this category. So I'm only looking in the given category. That's the only place I'm taking my numbers. So I'm ignoring all of this other stuff. I don't even have to worry about, any of this other stuff. Don't have to worry about any of this. Just in this category. So in this category, how many people exercised? 8. We want a probability that they exercised given they caught cold. So 8 people exercised. How many total? 18. In the given category, 18. So we're only looking at the given category. So our probability, 8 people caught cold in that category. Sorry, 8 people exercised in that category, because they all caught cold. 8 people exercised, and total of 18. 8 divided by 18, which I could reduce, if I wanted to 4/9, or about 44%. So about 44% of the people that caught cold exercised. So for a two-way frequency table, for conditional probability, two important things to remember. This little bar means given. So we want the probability of this after we already know this. And we go to our two-way frequency table and look only in the given category. And that's really all we have to do with two-way frequency tables. And the other part to the very first probability that we talked about, before we looked in our categories. Now notice that here on our first example, it didn't say given. It says find the probability that someone caught cold and did not exercise. So that's why that one was different. It didn't say given that they did not exercise. It says and. So when we have an and, we're just looking at the total number divided by the total number. So keeping that and in the given straight is going to be important. The given two-way frequency tables are nice because you can use find that conditional probability. All right, questions on conditional probability? Picking numbers out of our table. Okay. Stop this.